Hi, this is Aaron Newcomb, and on this episode of Floss Weekly, Guillermo Amaral joins me as well as Jonathan Bennett, and we're going to talk all about open hardware. What is it? How do you use it? What platforms qualify as open hardware? What platforms don't? You're not going to want to miss it. It's coming up right now on Floss Weekly.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Aaron Newcomb, Guillermo Amaral, and Jonathan Bennett. Episode 399, recorded on August 16th, 2016. Open hardware. This episode of Floss Weekly is brought to you by Drobo, a family of safe and expandable, yet simple to use, storage arrays. Drobos are designed to protect your important data forever. Visit drobostore.com to learn more and use the code TWIT100 to save $100 off select Drobos. Hey everybody, welcome to Floss Weekly. It's the show where we talk about not only open source hardware, but sometimes, not only open source hardware. I've got open source hardware on the brain. Not only open source software, but also open source hardware. That's what I meant to say. I'm Aaron Newcomb. I'm your host. Randall is still out, unfortunately, and we hope that he has a speedy recovery. So Randall, get better soon. But with me today, I have two lovely co-hosts, believe it or not. First is Guillermo Amaral. Guillermo, how you doing?
I'm doing great. Can't complain. Good. And it's a
Awesome.
Good topic, so I'm excited.
Yeah, a little bit different for us today. So we'll get into that in just a minute. But I also want to introduce our second lovely co-host, who actually we haven't been on together before. So this is kind of new for me. That's Jonathan Bennett. Jonathan, how you doing?
I'm good. It's good to be here.
Excellent. Boy, you're sounding so much better with without those audio issues. Or it's fun to troubleshoot all these problems we have before the show. If you don't tune in early, you miss. If you just watch the recorded version, you miss a lot. So you got to tune in early. But anyway, we're going to be talking today about a topic that's I know is near and dear to my heart, and hopefully near and dear to a lot of you watching, which is open hardware, open source hardware. Sometimes it's just referred to open hardware or open source hardware. What's the difference in those two things? We're going to talk about what it is, why it matters, and get into maybe some project ideas or some projects that we've built. We can do a little show and tell. And we're also going to have a little quiz and see if people can identify, at least our host can identify, and maybe if you're in the chat room live, you can play along, identify some of the boards. I've got a bunch of boards here, and I think maybe even Guillermo has some that I don't have. So we'll see if we can do a little guessing game here in a little bit. But first, let's just talk generally about open hardware. This is something that, if you haven't been following along, really started not just with Arduino, but started in a big way with Arduino when Arduino came on the scene and opened up their designs. A lot of people said that they were crazy to do that, right? Because it's all about making a physical product. And if you're making a physical product, you shouldn't, give your design specs out to anybody that wants them. But that's what they did. And, they really kind of changed things for the better, I think. But before we get too deep into it, let's go to Guillermo. Guillermo, do you, what's your background in terms of open hardware? I know you do a lot of projects, but, you must know a little bit about this, right?
Yeah, a little bit. Yeah, so I've been doing a lot of open source software for a while now. And I also studied electronics back in, junior high school, and just kept on doing that for a while. And then I found open source hardware, which is you guys may have seen this logo before. I don't know if that'll show up, that little gear thing.
Yep.
So I actually started looking into how people share their Gerbers and files. I guess I should probably just take a little step back and mention what Gerbers are. They are the basic schematics for a board that you can send out to a fab and just get a board made, right? By board I mean like an actual PCB board. So I found people actually sharing those, and then that just opened up Pandora's box for me, since I could actually see every single component inside a working dev board, for example, for stuff I do in work. And then I could just actually, start debugging problems directly on the board itself. So that is something that really started, I guess injected this open source hardware motivation into me. I just started doing projects and just releasing the Gerbers myself too. But
Yeah.
I guess, does that answer your question? I guess it does.
Yeah, no, absolutely. Well, I mean, one question I've always had for you is when you're doing software work and programming and everything else. I mean, do you actually get to the point where you have to deal with the board itself or the hardware itself and say, hey, this resistor value is wrong, or I'm getting some weird feedback on this dev board that shouldn't be here? I mean, do you actually get to that point and need to go in and troubleshoot the hardware?
When we're working on a dev board, like something pre-made, I don't want to give out any of the boards I have here right now, so I'm just gonna wait for that one. But when you have something pre-made, you usually don't run into those type of issues. You do have to hack on some of them. For example, you might get something like let's say a Raspberry Pi. Since we're gonna start easy here. You might need to disable something in there and take off a resistor, and then maybe plug into the some test pad directly to get access to some pin that you wouldn't normally on the board. That is something that I do run into a lot. And if it's actually fixing and trying to debug something directly on the board, that happens a lot on prototypes. So if I get assigned to work on a prototype for, let's say, X or Y car company, usually something does not break. Something does not work. Rather, it does break and doesn't work, and then we have to figure out why we're getting, for example, a pin is not getting pulled low correctly, or there is a lot of noise in the SPI bus or something. So I have to like pull out my oscilloscope and just actually debug that and take out resistors and such. That is a lot. That is something that happens a lot especially on like new dev boards that you're working on.
Right.
So yeah,
right.
It happens.
Yeah, excellent. Well, let's go to Jonathan now. Jonathan, we're going to talk about some software related things too in a minute, but I'm just curious, what your background is in open hardware or using a Raspberry Pi or Arduino or things like that. I mean, is that something that you're familiar with?
Sure. I've got a couple of Raspberry Pis around the place. I try to keep my fingers on the pulse of open hardware. Really, I'm kind of watching for the perfect board, and I don't know that it's come along quite yet. I kind of have a strange list of requirements for it to tick that box. One of the biggest ones being that it needs to have vanilla kernel support. And that's the one that kills me on so many of them. So I'm watching and waiting for the right one to come along.
And just for those folks that are, maybe not as ingrained in this as we are, maybe describe what a vanilla kernel is.
Sure. So the vanilla kernel is the one that Linus Torvalds releases. It is his code, no additional patches. It's just that. And we're at the point now to where x86 hardware, so Intel and AMD chips like we've all got in our desktop computers, for various reasons, those more or less all just work with the vanilla kernel. They don't need any extra patches to bring them up. They don't need a device tree to make them work. There's the BIOS layer there, and it just comes up and it works. But with especially ARM devices, they're kind of the popular ones that I see this a lot with. You flash, let's say, the newest Fedora release for ARM to an SD card. You try to boot it, and it'll come up. Usually, it'll get partway through the boot and just hang because there's something on the board that's not supported in Linus Torvalds kernel yet, and that's what Fedora ships. And because the bring up for the board has been done by a third party, by another company, they will a lot of times have their own kernel tree, and sometimes a few patches, sometimes a whole bunch of patches in that kernel tree. And those patches are what's required to get the board to actually boot up all the way and be usable. And for various reasons, a lot of us really, really don't like running those pre-compiled kernels that somebody like the Raspberry Pi Foundation or one of the other big players, they have these pre-compiled kernels. For various reasons, we don't want to run them. We want to be able to just use the kernel that comes with Fedora, for example. And it's can be quite the pain when that doesn't work. I've done a little bit of the hacking where, you go and you get the one patch, and well, is this enough to make it work? You apply it, you compile, you try to make it work, and that wasn't enough, or that broke everything. It can be quite the process.
Yeah, definitely, definitely. So, and the reason, and you alluded to this, the reason that vendors or third parties have to make these specialized, basically versions of the operating system and the core of the operating system, which we call the kernel, is because a lot of times because there's some sort of proprietary hardware in the mix. And that's why there's no support for it in the mainline kernel or the vanilla kernel. It's because of these proprietary drivers, maybe a proprietary video chip or something like that. And that's the case on a lot of these boards. And it's why when people talk about open hardware and they talk about Raspberry Pi, a lot of people will raise their hand and say, wait a second, wait a second, wait a second. That's not open hardware. So let's talk a little bit about what open hardware really means, or maybe there's lots of different versions of it that we have out there that are out there. But there's really at the heart of it is kind of what we've just been talking about, which is the specs for the board themselves are published so that anybody can take a look at the board, make changes, look at the various files that make up the PCB configuration, the schematics and so forth, see if that all goes together. But then it also goes to being completely open in the software stack that runs on the board as well. And so a lot of times people will claim that they're open hardware when really the software stack doesn't support that, because I believe anyway, it has to be both. You have to be able to, as Jonathan said, run a vanilla kernel on the device and have all of the hardware components themselves be open, as well as the layout of the board and all the other pieces. Guillermo, what do you think about that definition? Does that do it justice?
I'm not really sure about the kernel part, because I at least working on boards, especially when you have to do the bring up, it's not something that that will usually just work. You do have to muddle around in the kernel and at least release a binary device tree in some cases, right? So it'll kind of work with the vanilla kernel. But yeah, it kind of fits what I think open hardware should be. You should have the stack free. The software stack should be open, as in you can actually build it and you see it. Maybe the license can be a little flaky on there. It depends. And the Gerber files, which are the ones I mentioned before for the board, should be available. And of course, the schematics, which is one of the, I guess, least talked about parts when you're working on a board sometimes. But if you have to debug something, it does make a lot of sense to have. And if I remember correctly, the Raspberry Pi does, the foundation itself released the schematics for the RPi 1, Model B, and A. Only the schematics, not the board, not the actual Gerber. So I guess and I guess the part of the bring up the bootloader isn't free also. Or if it is, it's still tangled up in some licensing issues there with Broadcom. So yeah, I guess that one wouldn't really fit in the definition, as you, I guess, pre-alluded a few minutes ago.
The Raspberry Pi is an interesting case because the bootloader is actually the GPU chip. What happens is the firmware in the GPU looks at the SD card and finds the kernel image, and the GPU actually bootstraps the kernel. So for them to open source that part of it, they will literally have to release their GPU firmware, and good luck.
Yeah, that's not going to happen.
Yeah, that's just what I was going to say. That's the problem. It becomes very difficult, especially in the case of Raspberry Pi, when you're going to a commercial company that makes lots of chips and has a lot of skin in the game, so to speak, and they don't want their competitors to see everything that they're doing. So it's great that they were able to support this project. We don't want to knock Raspberry Pi too much on this, at least I don't, because I think what they're doing overall has a beneficial effect. Certainly on the ecosystem, right? They're getting a lot of people interested in technology. They're getting a lot of people interested in open source software, and kids and people are learning programming and all this great stuff. So we don't want to knock them necessarily. I don't, but they are using some proprietary hardware that the vendor doesn't necessarily want to, give up, open the kimono, so to speak, and let everyone see how their stuff is working. So so it's a little bit of a catch-22, and like you said, Guillermo, they did the board. They did release some of the specs on their early boards, but then they've stopped doing that. And I don't know if that's because there's been a lot of competition in the marketplace with some of the boards we're going to see later, Odroid and Orange Pi and Banana Pi and cheap Chinese knockoffs. There's been a lot of those. So I don't know if maybe that's part of the reason they haven't been releasing even the board specs of their later boards, or who knows? Maybe they just don't have time.
And yeah, I guess you're right. I guess with the recent one being the Onion Omega, I think, which is basically just a copied over clone of it. I guess they do have to kind of protect their IP. The one that I do know is the most open that they actually have is this one here. This is the compute module. Mm-hmm. So you can actually get the Gerbers for this. For both the board and the module itself. So you can get the boards and the schematics for the board. So basically you would need that if you are planning on building your own product. So, you can just have a base reference and build something off of that, right? So it's going to possibly work, because if you're dealing with hardware, it usually never works, at least not the first time. So but yeah, that's the most open one. Of course, as Jonathan mentioned, the bootloader is just not going to be open at all unless you can probably buy more than I think was 20,000 chipsets from Broadcom, so you can get access to the I guess get the privilege to sign the NDA and actually get access to the data sheet for the chipset there. But it's a starting point, so that's good. It's better than nothing, I would say.
Yeah. Well, let's talk a little bit about what I referred to at the top of the show as maybe not the original, but certainly the system or the board that kind of kicked off in a big way open hardware and open source hardware, which is Arduino. And there's some controversy there, I guess, which we'll talk about in a minute. But Arduino really does release just about everything that they can on the board. I think that they are, even though there's firmware running on the board, I think they're it might be a little bit easier for them to release everything because the chipset itself. And I know some people will argue with me about this, but it's just a microcontroller, and people say, no, it's a computer, and it is a computer. It's got all the components, I know, but it's a little bit different than a Raspberry Pi, where you have a something that's trying to be a desktop system, as opposed to our Arduino, which really wants to be a single-purpose type of system that does something very well. That maybe it controls a robot, but that's all it does, or it's running some sort of, like, I've done lots of Arduino projects where it does one set of things really well, and that's kind of all it does. And typically people don't use it for multi-purposing, like 20 different things at the same time, because it just doesn't have the memory and the system resources. Any thoughts on Arduino in terms of open hardware? What's your experience with Arduino, Jonathan?
I have an Arduino somewhere. I've used it a little bit. Back when I was a teenager, I did a project or two with it, and parts of it were impressive. It definitely did kick off for a lot of us this idea of open hardware and being able to put our hands on hardware to tinker with it. So it's definitely a good thing there. I'm very interested to talk a little bit more about the controversy with Arduino. Maybe the idea even of what happens when a hardware project forks, because that's kind of what they're looking at.
Right. Well, we're going to get into that in just a minute, because it's certainly, in terms of this ecosystem that we're talking about, it's certainly one of the big news that's been going on for over a year now. But we'll talk about that in just a minute. I want to give Guillermo a second too, because Guillermo, you must use Arduino quite a bit, right?
Well, not Arduino itself, but I have used the chipset they based the Arduino on. And I think I have a couple of boards around here that actually use that same chipset. They're in a stack somewhere. But yeah, I personally, well, first off, let me say, Jonathan, you just made me feel super old by saying you played around with it when you were a teenager. Okay.
Me too.
Oh, sorry.
Okay. Just putting that out there because yeah, my daughter's 18. So I'll let you make the calculations on that for a second. But yeah, I personally like them a lot since they are fairly easy to work with. You don't really have to have a special programmer. You can just program them directly with the chipset, which is something that I always found the USB chipset included on there, just to be clear. Yeah, that is something that I've always found super funny with those things, was that you have a stuck-in chipset on the Arduino that is technically more powerful than the first one, the actual one you're programming. At least if I remember correctly, it is. But you do have access to actually flash both of them and do something really wacky with the Arduino if you want to, work off out of the standard Arduino ecosystem, if you will, and just actually program both the chipsets. They're bare metal. You can, and that's super fun.
I remember hearing about that. Apparently, there were some people that were trying to get their Arduino to act like a keyboard or a joystick because you could reprogram the USB chip. You could make it into a different device.
Yeah, it's actually way more powerful. So you can actually make it just act like anything you want. I'm not sure if you guys are familiar with the USB rubber ducky, for example, which is okay. Well, there you go. I'm just gonna give a little overview. So it's a device that the Hack 5 people came up with that you basically just program. I think it does use an ABR in there, if I remember correctly. Which is programmed to act as a HIT device, a human interface device. And you can just add some scripts in there and just make, whenever somebody plugs that into your computer, it'll just go through the script and, make keys, hit and, do wacky things on your computer. Obviously, some not good, some just funny. And I saw a few people actually doing that with the Arduino, just standard Arduino. When somebody just goes in to plug it and start programming, it would actually start doing things on their computer, which is hilarious. But yeah, you can do a lot of things with that.
Yeah, that's great. In fact, that's one of the things I'm going to be using on Arduino for. It's on my bucket list. My project list keeps growing and growing. But I'm making a Pi top, which is like a Raspberry Pi. In this case, I'm going to put something else in there, probably an Odroid. You take an old laptop or you build your own laptop out of a Raspberry Pi. And I'm doing that. And one of the problems I have is I want to use the keyboard that came, whoops, sorry, dog's barking here. The keyboard that came with the laptop. Hey, quiet down. And the problem is that I can't interface. It's got some sort of weird interface on it. It's not like a nice USB interface that you get when you plug a keyboard into the Raspberry Pi. It's like, you just got a ribbon connector and you've got to figure out which pins go where. And so the one thing I want to do is use on Arduino, just as you were saying, you can turn the Arduino basically into a keyboard controller, a USB keyboard controller. So what I'll do is I'll plug all of those connections from the keyboard into the Arduino, and then the Arduino will plug via USB into the Raspberry Pi, thereby creating my, allowing me to use the built-in keyboard on the laptop. And it's actually that project that's keeping me from moving forward, or that part of the project that's keeping me from moving forward, because it's kind of complex and you have to map out the keyboard, and so I don't know how. I'm not feeling up to the task right now when there's all these other things I want to be doing. But it is a very cool platform. And we're actually going to be looking at those in just a minute. We're going to do a little quiz here at the end of the show. I've got some boards and Guillermo has some boards, and we'll see if we can figure out which ones they are. There's also some controversy around Arduino that I want to get to here in just a minute. That's cropped up basically in the past year and a half, and it's still ongoing. And there's even news about it that just came out a few days ago that we'll talk about in just a minute. But before that, we want to actually thank our sponsor. We've got a great sponsor this week for the show, and that's Drobo. Now, Drobo actually offers a family of storage arrays for protecting your data. I know a little bit about this, working in the storage industry. These are great little systems for your home. They offer systems that connect directly to your PC or Mac via USB 3, Thunderbolt 1, or Thunderbolt 2. And they also offer a network storage device for sharing and backing up networks of users at home or in the office. And in the spring of 2008, Drobo invented the concept of exposing the server embedded in NAS appliances to developers, something close to what we're talking about today. It launched its Drobo Apps program to developers, a practice that's been copied and adopted by other leading NAS vendors. The Drobo 5N and 810N are network storage systems, and their capabilities can be extended with Drobo apps, which are free applications installed from the Drobo dashboard. They include cloud apps that let you back up to 2 different cloud service providers or sync to their mobile computers and mobile devices via BitTorrent Sync, for example. Developers tools for programs and websites. There's a full LAMP stack in Node.js along with WordPress for web developers. Also, app developers can use C, Go, Perl, Python, Ruby. There's even a Git client that lets you develop on your Drobo 5N, and there's a software development kit available to support programming. It also does things like home entertainment. You can put your media collection on there. You can run an email server on this thing. It also allows you for remote access. So when you're not at home, you can take a look at what's going on your system. The My Drobo and Drobo Access apps are built using well-known, well-vetted open source solutions like Let's Encrypt and OwnCloud, which I just think is awesome. So if you want one, visit drobostore.com. You can learn more or check out their complete line of products. In fact, Twit listeners can save up to $100 off their purchase of a Drobo Mini, Drobo 5D, Drobo 5N, or any 8-drive or 12-drive systems at drobostore.com by using the code TWIT100. That's drobostore.com, and use the code TWIT100. And we definitely thank Drobo for their support of Floss Weekly. And it's a cool little system. You guys should really check it out. Right now, let's go ahead and talk a little bit about the controversy, because what happened with Arduino actually is there was a bit of a break in the people that kind of founded Arduino. And we should say maybe a little bit of background here about Arduino. It was really founded by some folks that wanted to blend kind of the artistic creativity side of things, make things a little bit easier for people to create things using electronics. And so they developed their own IDE. They developed their own board, which uses the generically, at least in most cases, uses the Atmel line of chips, and then it kind of exploded from there. Now there's boards that you can get that support Intel chips and other chips. But it started with the Atmel chipset, the AT Mega chipset. And they really wanted to make it easier for people to create things. I don't know if it has anything to do with the fact that they're Italian, but they were really into this creative aspect of designing things with electronics. And so they made a really easy IDE and published that. And like we've already talked about, they published their designs, their specs, the PCB specs, as well as a lot of the other stuff that they had. It was basically all open, and they wanted people to create things with this new device. And they had a lot of success. But then just a while back, about a little over a year ago, there was a little bit of a split in the leadership. And I don't pretend to be an expert, so you're welcome to correct me where I'm wrong here. But basically what happened was there was one group wanted to basically continue to give these specs out and let people build clones in other countries. And there was some trademark issues there where they had some legal requirements. And then another group said, no, we want to keep this to ourselves, keep it private, maybe have it just basically to ourselves. And so they created their own license, because there's, of course, all around the world, there's all kinds of different licensing agencies, trademark things that you can do. And so there ended up being 2 competing Arduino, if you will, brands that came out, and one is now known as Arduino CC, which is their website. That's the original Arduino folks, and then the one that spun off really is Arduino.org. And they're still kind of fighting to this day. In fact, just recently, Pi Moroni, which is I describe it kind of as the Adafruit of the UK, where you can get a lot of Raspberry Pi stuff, but they also carry Arduino products as well. They basically said, look, we're not going to carry Arduino anymore because we have so many different regulations from all of the the 2 different groups telling us what we can sell where and what we have to call it and where we license it. We can't deal with that anymore, so we're just not going to even carry Arduino. I think that was just last week that came out. So it's really starting to affect them. And I don't know if Guillermo or Jonathan, if you guys have any more insight onto this, anything I missed in that explanation of what was going on.
One bit of news that just came out on Friday is apparently Pi Moroni has contacted Massimo Bonzi directly and they are talking with him about the issues. And according to the blog post, they are confident that changes will be made to fix the situation for resellers. So hopefully Pimoroni will not be permanently dropping the Arduino line. It's just temporary while they try to get some things straightened out.
Okay, good. Yeah, I hadn't seen that yet. I mean, as you can imagine, things like this really have an impact on resellers, people trying to sell the boards, because especially in a global marketplace like we live in today, people have websites in all different countries. And when you go to that website, you know, what are you allowed to sell? Are you allowed to sell them the Arduino.org board or the Arduino.cc board? And you know, I've just got to be honest, for there's a lot of knockoff boards out there too. And you know, I mostly use the knockoff boards. I mean, I'd like to support people that you know started the project and developed the project. But when it comes right down to it, you know, if you can buy 20 of these things for $10 from someplace, it is an open spec. Anybody can create these boards. A lot of times I'll just go use those. And I think that the risk here is that a lot more people will start to do that. They'll say, you know what, if I can't get my board at Pimoroni, or if I can't get my board at Adafruit, of course you can right now. But if that ever changes because of all these conflicts and things, I think that they're going to lose. It's basically a black eye for both of them, no matter which one you agree with their approach. I mean, it's a huge black eye for both of them. And I think the risk is here that they're going to turn off their core audience.
At least we know that you can probably still buy it at Radio Shack, right?
If there are any Radio Shacks left.
No, yeah, I have very little insight on this because I only started looking into it when, you know, the actual split happened. But I do know there is a big battle with the actual intellectual property name and the actual name, you know, to be able to use the name in the US and in Europe. So I don't know if Jonathan knows a little bit about this more than I do. I just know that they were one of the problems with the whole split was that they wanted to keep the name or registered the name, if I remember correctly, in the US or maybe it was in Italy. Yeah, I'm not really sure, but I do know there's a issue with the whole naming there. Maybe you can fill in a little bit, Jonathan.
Sure. I'm by no means an expert on it either, but I've followed it just a little bit closer, it sounds like. And first thing we need to talk about is, because it's open source, there is this concept of, yes, you can fork. I'm not sure exactly what license Arduino uses, but basically every open source license has this idea of a fork. And when you first look at it, you might think all of this is because Arduino and Arduino forked and went their separate ways. But that's really not what the issue is here. In fact, you could look at all of those knockoff boards and say that they are forks of Arduino, and there's not been this problem. What really the issue is here is that one branch of Arduino owns the trademark in the United States. They own the Arduino trademark. The other branch owns the Arduino trademark everywhere else. And so it's not that there's just a fork, but in this fork, both of them are claiming to be, but also have some legal means to say that they are the legitimate Arduino. And so I think really the trademark fight is probably the one that's the worst about this situation, because again, they both have some legal recourse here, and it's yet to work out. I mean, I think it's pretty clear which group the market wants to go with, but as far as the legal side of it, it's yet to work out. Yet to work out which one is legitimate and which one is going to maintain the worldwide trademark.
Right. And there's actually a great blog. Hackaday's done a lot of work on this. They've covered this, you know, in depth. And if you are interested in this discussion and where it's at, because it's always changing, unfortunately, like I said, a little bit of a black eye, but you know, Arduino is such a great product and such a great board for people to learn about computing and programming. If you want to follow this, you can just go to Hackaday. It's actually hackaday.com/tag/Arduino-vs-Arduino, Arduino versus Arduino, or just search for Hackaday and Arduino versus Arduino, and you'll come up with this. And it's a list of all their blogs. They actually did some. They actually interviewed both sides. For example, Federico Musto and Massimo Banzi, who was the kind of is the father of Arduino, if you will. They interviewed both of them to get their feedback, which I thought was really cool. So you can go out and read those interviews and see all of the interesting things that are going on. It's just it really is too bad, but it's also very interesting in that it may have an impact in exactly what we're talking about, which is the future of open hardware. This may have a chilling effect on the industry in terms of, hey, we don't want to get into the trouble that these guys had when they tried to do an all open source hardware type of product. And so it may discourage folks from doing that. And I hope it doesn't. I really hope it doesn't, because it's really important. It can be really important to folks to have access to the technology and be able to run it in a way that they know what's going on. Quite simply, as both Jonathan and Guillermo talked about, sometimes you need to know what's going on in the system. And if you have things that are closed source or built specifically for your board, or parts of your PCB that you're unwilling to tell everybody how you came up with that particular configuration, or why is that like that, and it can be problematic. It's certainly not as good for the community as an all open system would be. So we certainly hope that this gets resolved soon. There are other open hardware boards. We talked about Raspberry Pi, which is sort of open. We talked about Arduino, which is open, but is having some difficulties. But there's other open systems as well. I don't know if either of you use a BeagleBone. I don't want to give away which boards these are. I want to show it, but I'm not going to yet. I don't know if any of you guys use BeagleBone products like a BeagleBone Black.
Yeah, I have both the BeagleBone and the BeagleBoard, the BeagleBoard Max, if I remember, XM, which I will also not show just in case. But I've actually used them before. I totally forgot I had a BeagleBone Black here until I was talking with a friend a couple of days ago, and I looked through my box and I found one. So, yeah, there you go. Go ahead.
Oh, sorry. I was just going to say I've got a couple of BeagleBoard products around here somewhere. I don't have the time to look through the stacks to find them, but it's somewhere. I've used them.
Cool. Awesome. We're going to talk about that more in a little bit. And there's also a lot of activity on Kickstarter. It sounds like Guillermo and I probably follow this pretty closely, but I'm always backing these projects on Kickstarter. And that's where some of the more obscure boards I have, or at least maybe obscure to some folks in the audience. So we'll see if you guys can recognize them. But I love backing these Kickstarter projects because sometimes they really come up with something new and interesting. And a lot of times it's less expensive or maybe more expensive, but it does something really cool. One example that I don't have in front of me yet because I haven't got it yet is a product called Snickerdoodle. And we actually interviewed the creator of Snickerdoodle here on this show. You can search for it on twit.tv. And that's one of those boards that's an interesting take on something that's different in the fact that it includes FPGA resources, and it's configurable FPGA, which is a fancy way of saying you can configure the board in any way I want to say any way you want, but you configure some ports to do one thing, some connections to do one thing, and then later on you can change what those connections do to do something else. Whereas in most boards you have dedicated, for example, GPIO, general purpose input and output pins, and sometimes they can be changed a little bit, but they're pretty much set at whatever you get. But in an FPGA board, you can actually change those resources around, make your board do different things that it wasn't capable of initially. And so I think, boards like that are very unique. And that's why I love seeing these projects come out, especially when they are open source hardware, at least as much as possible, because then you really, the creativity, I think, really starts to flow there. So really cool things. Anything else you guys want to talk about in terms of open hardware before we start going with the board quiz here?
You bring up FPGA boards, and that is actually, I guess, very relevant to what we're talking about right now, because you can, as you mentioned, actually program what the chipset will do. You actually program in the logic, but there isn't that many options into the in the way of actually programming that which is open, right? You don't have the tool set or the tool chain to be able to program a lot of FPGAs currently. And I'm not sure if that fits into the whole open source hardware or how that looks to you guys. If that you would consider a board with an FPGA on there, that the whole board spec is actually open and available. You can get the Gerbers, you can get the schematics, you can even get the BOM file, which is the file you with the whole list of parts you need to purchase if you want to build your own. But you don't have access to the actual tool chain, which happens a lot. You can actually get them before. Again, I'm going to date myself. You had to pay for the tool chains. Right now they're free, but they're not free as in beer. I mean, they're free as in beer, but not free as in actually be able to modify the code or see what's going on there, or be able to program your own directly without a license of some sort. So I don't know how you guys think about that, or would that still fit in the open source hardware or not?
Well, that's a great question, and again, I would recommend folks, and we didn't really get into this in the interview, unfortunately, but I highly recommend people go check out Snickerdoodle. I believe that they've delayed their rollout, as most of these projects do, just because they have trouble with sourcing products and things like that. But I would say go take a look at it and see if this is any different from what you're talking about, Guillermo. I don't know that it is. I'm just scanning the website myself here. I know that they tout that they are open source friendly, in that you can run things like Ubuntu and different Linuxes on the board. But in terms of actually opening up the tool chains and things like that you were saying, I'm not sure if they do or not. So, but I'd highly recommend folks take a look at that project, and maybe we can ask that question or have a follow up at some point, because it is a cool board, a cool idea. I think it's quite different than what we typically talk about. And when we talk about Raspberry Pis and Arduinos, it's really something. There's a lot of clones, a lot of things that are similar, but this one is really different. So I think it's kind of interesting. How about you, Jonathan? Anything else before we move on to the board quiz?
Sure. I was thinking about this just a little bit, and we can define open source hardware in a couple of different ways. But if we want to be too much of a purist about it, we almost get to the point to where nothing is truly open source hardware, because each one of these boards have various chips on them. Well, are the schematics for the internals of the chip open source? May or may not be. The firmware that runs on the chips, are they open source? They may or may not be. And kind of what you come to is, when you talk about open source hardware, for each of us, there's a different set of requirements, different set of things that we care about. So for me, one of the things I really care about is this idea of you can run a vanilla or a mainline kernel. For someone else, it might be, well, the firmware needs to be open so that I know it's not doing anything, that I can't audit. For someone else, it might be, well, I need the schematics of the board to be open so that I can build another one if I ever need to. So it's interesting to look at the even between the three of us, the different ideas about what truly makes for open hardware.
Yep, absolutely. In fact, on the in the chat room, Micro pointed out, if you go to GitHub, github.com/critical, that's KRTKL, you can see Snickerdoodle's schematics and layouts and board files and things like that. But in terms of the FPGA, I'm still not sure what you can do about that. But they do have the models, the schematics, the board file, the gerbil files, and all those things are already open. So they're trying to be as open as possible. But then, like you say, it depends. How far do you take the argument? How open do things need to be, and when does it become a barrier, and when does it become an enabler? And so it's an interesting debate that'll have to continue on, I guess. And all we can do as enthusiasts is offer our support for people to make things as open as possible, so that people can build really cool projects like we do. So I think we ought to talk a little bit about. Let's do this. Let's talk about give people an example. Again, I'm thinking of people that maybe are in over their heads on this conversation and are just getting started on Arduino or Raspberry Pi. Maybe talk about just one project Guillermo, that you've built, and I'll come up with one as well. And you don't have to show it off or tell too much about it, but just to give people an example of what you can build with these platforms.
Okay, so a good example would be when the Raspberry Pi came out. There wasn't, first off, the original kernel, which again was a modified kernel. You didn't have any way to be able to power the system up and shut down the system cleanly. So I think maybe about a month or two ago, after that, I actually started making my own power supply for the Raspberry Pi. And it turned out to be this one. This is the last one I actually built. I started working on one that has SMD components. This is the third rev I did. So you are able to plug this straight into the Raspberry Pi. As you can see, there's the little logo. This is the board I showed off at the when we started the talk here. You can plug this into the Raspberry Pi. It'll start up the Pi with this by pressing this switch here, the power switch. You can long press this and it'll automatically shut down the Pi cleanly for you. And it does a lot of other things, like you can just press. It basically acts like a button you would have on a cell phone, right? So you can make it do things like if it's pressed twice, maybe start up X11. If it's long pressed and then just single press once, do whatever. Maybe turn on the HDMI port. So that is something that I started working on a while back. Haven't really updated it since they actually added in a few, I guess you're calling them snippets or something, overlays. That's right, overlays that you can actually use on the Raspberry Pi. And they added some to basically do the same thing now. So you can say, I want this GPIO pin here to power off send the signal to the kernel, which will power off the system, or have one to toggle a reset. So you probably don't need this anymore. So I haven't really updated it before. But that is actually available on my GitHub. If anybody's interested, you can just Google my name, Amaral, on GitHub, and you'll be able to get the schematics, the firmware for the chipset. And this one here uses the AT-Tiny, which is if you are, let's see if that is focused there or not. Doesn't want to focus. One of the little brothers of the AdMega 328, which the Arduino uses, if you will. So if you are comfortable working with the Arduino, you can probably, actually just build a board and program it yourself and make it do whatever you want.
Oh, that's awesome. Is that the 85, the AT-Tiny 85?
Yeah, that's it. That's it.
Where it's getting competitive now. Yeah, so I didn't know about the overlays, though. That's something I'm going to have to check out, because I know I still use a board. And I love the fact, by the way, that you put, before I forget to mention, the open hardware logo. If people don't know what that is, the little gear logo with the notch cut out of it is the open hardware logo. I love the fact that you put that right on the board itself. That's fantastic. But I've been using another product that someone came out with. I can't remember what it was called. Pi ATX Power something.
Oh, yeah, I've seen that before.
I can't remember the exact name of it now, but it's basically a similar thing. It gives you, computer, desktop computer like button functionality that adds to the Pi. It sounds like very similar to what you did there, but they haven't made any updates to that in a while. But I wasn't aware of the overlays, so now I'm excited. I got something to do. As soon as we're done with this, I'm going to go check out the overlays, because I'm still doing things like writing my own shutdown and reboot scripts to watch for interrupts on the GPIO pins. It sounds like it might be an easier way. There's also a run button on the Pi, on the newer versions of the Pi. I don't have my newer version with me. I've just got an older one that has a run button right on it. But unfortunately, that run button, I believe, turns the chipset off immediately. So you still could end up with corruption issues on an SD card in that case if you use that button. Chat room, feel free to correct me if I'm wrong, but I believe that's the case, that little run button on there doesn't work the way that you would hope that it worked. Anyway, Jonathan, anything else from you before we get into a quick board rundown here?
Sure. So an interesting project that I've got that might give people a better idea about what you can do with these. I've got a stereo over in the other room, and sitting on top of it, there is a Raspberry Pi. And I'm using the audio out port to go into the stereo's inputs. And there's a little program called MP Droid that is running, MPD, Music Player Daemon, that's running on the Raspberry Pi. And I've got a bunch of music loaded into that. And so I've got it set up to where MP Droid is the name of the Android app. I can pull it up, scroll through my music collection, and play something through the stereo. Got that wired through the house. And then on that same Raspberry Pi, it's also running a tiny little asterisk phone system that makes the phones ring in the office here. And so you can do some interesting things with the Raspberry Pi. For example, in that one, I've got it set up to where if music is playing and somebody calls me, the music pauses, the call goes. As soon as the call's finished, the music starts playing again. And it's just nifty to be able to pull those different things together in a tiny little platform like the Raspberry Pi.
That's awesome. That's awesome. I use MPD as well on the project. I guess I'll just use this as my example. I took an old 1942 Philco radio and used the Raspberry Pi to actually bring it back to life so that it actually plays period music and radio shows from that time period. And it's not just streaming the audio. It also does, you can use the MP Droid app to control what the playlist is and what songs are playing if you want to do that remotely. But I've also got it integrated into the actual physical buttons and dials on the radio. So if you turn the volume up, it actually turns the volume up on the radio. If you change the tuner dial, it actually recognizes that. It plays about 7 seconds of like static or dial searching noise and then goes to the next song in the playlist. And it's funny because when I turn this thing around and show people that the radio isn't powered on and the cord's actually cut, even though the guts are all in there and it looks really cool with all the tubes and stuff, like they can't believe it. They're like, "What? There's no power going to it. How do you do that?" And I was like, "Oh, I've got a battery and I've got a Raspberry Pi, and magic just happens." So that's cool that you're using MP Droid. That's awesome.
So your radio project there is officially one of my bucket list projects. That's one of the things that I would like to do is get one of those old radios. When I do it though, I intend to actually use the tube amp that's in the radio to get just that little bit more vintage sound out of it.
Yeah, that's awesome. Mine wasn't working. That was my original thought. It wasn't working, and I thought, you know what? I'll just get some. I'll just do this all with the Raspberry Pi, and it worked out okay. But that's even a. In fact, when I bring this project to maker fairs and things like that, you always get the guys that come up and say, you could fix this if you had a tube analyzer and blah blah blah. I could fix this up for you. And it's like I just appreciate all of that knowledge that goes into knowing how to fix all that stuff that typically we don't even use anymore. Okay, let's do we don't have a lot of time. I guess probably have about maybe 10 more minutes here. So let's just do let's do a little board quiz and see if, let's start with an easy one and see if you guys can get this. I'm sure chat room, feel free to follow along here. But this is going to be an easy one. So you all should know what this is, right?
It's the
Raspberry Pi. And this is actually, I believe, the first version of the Raspberry Pi. And if you look closely, you can tell that this is off because I actually broke off the SD card holder, and I had to actually solder another one on there, and I soldered it on crooked. Okay, so that was easy.
Wait. I'll add a little detail there. That is the B plus model of the RPi 1.
Yes, exactly. You got it. Yep. In fact, this is I'm trying to read it on here. It's 2011-.12 is what it says. And I believe this was the original that I got when it first came out. Okay, should we move on to another one? Let me just pick out something. Okay, so we mentioned this before. And let me hold this one up. I'm going to let Guillermo do a couple of these too. Any clue what this one is? It should be
that's easy. Come on.
Somewhat obvious by the shape. Yeah, Beagle Blown Black. Good job, Beagle Blown Black. Beagle Blown Black runs Linux, and it was one of the early boards actually to be able so that that you could use like an Arduino, but actually run a full Linux stack on it as well. So it's kind of cool. Let me do one more, and then I'm going to throw it over to you, Guillermo. So get ready. I don't want to go too obscure here. Let's go with. This is an interesting one. Let's go with this one. Any clue what this board is here? I don't know if you can see the silk screen on there or not. I don't want to give it away if you can, but any clue what this board is? It's been in the news.
I have no idea.
So I believe it's all open hardware as well.
I like how Jonathan tilts his head to be able to read it.
So this is actually a chip. So this is the $9 computer that created a buzz maybe a year and a half ago, saying they were going to come out with this $9 computer. It was the world's first $9 computer. And it was a Kickstarter as well, actually. And I got this in not too long ago. It's actually a pretty good board. It runs a full desktop, which I was surprised at how snappy the desktop was. And you can do some really cool things with it. And they've got a lot of GPIO pins on here. There's just a lot going on with the board. And you can actually get the pocket chip thing that you plug this into, which gives you a little screen, and it comes with buttons, and you can play games on it and stuff. So really neat board. I'd highly recommend checking it out if you haven't already. I've got a few more, but
interesting point. If you like the chip. What was the chip boy, or what's the name of the?
Yeah, it's called the pocket chip.
Pocket chip, that's right. If you like the pocket chip, it comes with the Pico 8, I guess, development environment, if you want to call it. It's like a fantasy console thing. I made an image that you can probably, if you just Google my name or Amaral or whatever, or just check out my YouTube channel. I made an image that you can use on the Raspberry Pi, and it'll basically turn that into a Pico 8 console too. That is, if you ever check out the pocket chip website, you'll see that little game playing around. You can just do that on an RPi 1, 2, and on the 0. So cool. just a little add-on there.
Nice. Well, do you want to show us some? I know you've got some boards that probably I don't have. So do you want to show some of those off? We'll see if we can guess what they are.
Okay. So you want hard or easy?
I think we better do easy, or at least because I know you've got some hard ones there.
Okay. Okay, so have you ever seen this one?
Yes. I'm trying to think what it is, though. I know that because it has the offset pins. It's not a Yun.
Yeah, you'll see the name right there.
Nucleo?
That is a Nucleo. That is the ST Nucleo. So these use the ARM Cortex. This one is the ARM Cortex M3, if I'm not mistaken. I have the other one here that has the Cortex M0. So basically, you can they are like if you like playing with the Arduinos, for example, these come with a whole tool chain that's called Embed on the. You can basically just download that from the website. You can program them on the web. Also, you just type in programs that'll generate the firmware for you, and you can just flash them directly using USB. It comes with the debugger on the board. So if you want to try something like OpenSTD, you can actually just basically debug the board directly, see what the processor is doing, everything else. And these things are maybe like $10. So they're fairly inexpensive, and they are super flexible. You can actually just cut this thing part, the programmer part out, the top board, and you can use that afterwards. So if you build your own board, you can actually still use the programmer here and just both power and program the chipset afterwards. So it's fairly flexible. I really like these ones. One of my favorite. Yeah,
I think where I've seen that before is I think at our makerspace. Is that a microcontroller from was it STI?
That's right, ST. So
that's where I've seen it. One of the people that comes to our Raspberry Pi Arduino nights brought one in, and they were trying to work on programming some drivers for it or something. And I was like, oh, that looks pretty cool. I didn't know you could break that off like that, though. That's awesome.
Yeah, you just break it off, and you can use it separately.
Okay. Any other boርds? That was a good one.
Okay. Yeah, that's a good one. Okay, I'll try this one. This is fairly popular, and I'll give you a little hint. It is not ARM.
It's not ARM.
I'll give you a little closer.
Yeah. Oh, there you go. It's a little better. It's not ARM. It's not a Yun, is it?
No.
Arduino Yun. Okay, I give up. What is it?
So this is a Minnow board. Max.
Yeah, okay.
It uses it's a 64-bit X. What do you call this? X64 something or other. Basically, you can just run like desktop applications on this thing directly. Funny story. One of the guys who worked on this is from Intel. One of the guys who worked on this thing is actually started a YouTube channel recently with a lot of instructional stuff. You can just search for I think it's Dave's Deb Lab. He's Dave Anders. I'm just gonna give him a little plug. The guy's great, and he does really great work. This is one of his boards here. So, you want a harder one now, or is that
one more, and then we'll see if Jonathan has any that he wants to give us. And I've got a bunch more, but we're going to run out of time, I think.
Okay, so this is going to be somewhat hard, but you can probably it's still fairly popular.
I need to make my screen bigger so I can see these things. Oh, there we go. I don't know what that is.
You could probably see it has a Spartan chip on it, so it's an FPGA board.
That's what I thought, especially, and also FPGAs usually have the smaller pitch headers on them as well, which it looks like that might have.
Yep. So here's the name.
Oh, Mojo, nice.
Yeah. So I'm sure a lot. This thing I think started off as a Kickstarter project too. So. Cool. And I'll finally just show you this one. This is the one I couldn't remember the name of. It's gonna be super hard. I remember the name now. It's Hackberry, if I remember correctly.
Oh yeah, Hackberry. I forgot about
Hackberry. That. Yeah, the company who made this, I think, just went away. So, yeah, good luck finding anything for this thing. But this basically runs Android, so it's not too hard if you want to get it working. But cool. There is a lot of proprietary binaries you need to stick in there to actually get this thing working. So, yeah.
Awesome. I had some really cool boards that either I haven't used or don't know a lot about. So it's great to get a good variety here. Jonathan, do you have anything that?
I've got one. I've got one that is of interest. It's this guy. Oh, my poor camera.
Oh, that's one that I have sitting here too. So I know what that is. I don't know if Guillermo knows.
I'm not sure.
All right.
So that should be the Pine 64, right?
Yes, the A64 that, you really can't read there. Yes, it's the Pine 64. As far as I know, it's either the only or one of the only actual 64-bit open hardware boards. Runs an ARM64 chip. That's good, but the downside is that is an all-winner chip, which are notorious for not being open source friendly. So we are not yet at the point with this one where it'll boot the mainline kernel, but maybe one of these days.
Yeah, but it's a good step. I certainly got one. It was I think they were selling for like $15 or something initially, which was cool that you could get a 64-bit board for $15 on Kickstarter. And it's a little big. It was a lot bigger than I thought it was going to be, but it is a cool board. And we should say that Raspberry Pi 3 is 64-bit as well, although they're not running in 64-bit mode. So the operating system is running in 32-bit mode. But
yes, the Raspberry Pi 3. You cannot run in 64-bit mode, and that goes back to the closed source firmware. They've got to do some firmware tweaks before it actually unlocks the 64-bit stuff on the board.
Right. So eventually they want to come up with that, want to be able to do it, but they can't do it right now. I'm going to show you a few more boards. You mentioned, I think you mentioned hard kernel. So I wanted to show, or all winner rather, and I wanted to show these two boards side by side. Maybe I don't know if you let me get it. There we go. So these two boards, if you have any ideas, shoot them out. This is the lightning round, by the way, so you got to shout it out really quick. Anybody know? Anybody know? Anybody know? Okay, this is
Orange
the
Pie?
What?
Orange Pie?
Yes, so that's Orange Pie there. You can see the
I just
logo.
read the title there.
Yeah. This one, yeah, that's okay. This one's actually Odroid. This is the Odroid C2, really powerful system. They use the all-winner chips, both of these. So again, not necessarily completely open source friendly, vanilla kernel friendly, but you can do some really cool things with these. It's a lot easier to run Android on these because there's support in Android for the chipsets and all of the features in here, which there's not on the Raspberry Pi. So you can actually run native Android here. Works really well. They're working on getting that going on the Pi, but they don't have that yet. So if you want to run Android on a little system like this, I'd highly recommend checking out Odroid C1, especially for some other reasons I'm not going to get into right now. This one should be fairly easy for you guys. You know what this is?
Oh yeah, I've got one of those.
It's the Pi Zero.
Right, and you can tell the Pi logo there, but that's a Pi Zero. Kind of hard to get, but they're getting easier to get. And I wanted to do one more here. I won't go too obscure. So here's one more platform. This is a microcontroller platform. And the real brains of it, is this module that you can see is soldered on right there. That's the real. This is a dev board, so that everything else is broken out. Any clue what this is? It's one of my favorites now.
Something with Bluetooth on it.
So it's actually an ESP8266.
Okay.
ESP8266, which started out as a free way to add Wi-Fi to Arduino boards, and then somebody brilliantly said, you know what, this controller that's in here, we can actually run firmware on it, and we can make it compatible or at least friendly to use for Arduino folks. So they built in another board version into the Arduino IDE, and this is about $5 or less if you buy them on eBay, and it has Wi-Fi built in. A lot of the Arduino stuff is supported on it, so you can just program in the Arduino IDE, upload it to the board. And the other day on social media, I mentioned I think my next project is going to be to take that chip, just the module itself off that board, and then incorporate that into a watch and make my own digital watch with it. I think that would be a lot of fun.
I saw somebody that did something similar, right, recently.
Yeah,
an
exactly.
ESP watch, yeah.
Yeah. And I linked to that in my social media. I linked to that post and I said, oh, this looks so cool. I've got to do it. Because I've already got the OLED display. It's a little like 1-inch OLED display. I've already got that working and doing graphics and things. So I'm already, halfway there. I just have to like maybe 3D print a watch housing for it so that I can actually put it inside there and wear it around. But I think that would be, I don't know if it's good, how hot it's going to get, or how long I can make it last on a small battery or something like that. But I think it's going to be a lot of fun to play with. People geek out. What kind of smartwatch is that? I don't know. Maybe not. Maybe they'll just laugh at me. Who knows? I think it's cool though. So, okay, guys, we are at the end. We've talked a lot about open hardware. It's been a great show. I want to thank both of you for coming on. But since we don't have a guest to ask if they have any last thoughts, do you guys have any last thoughts you want to share with our audience about open hardware before we wrap things up?
I've got something. I've been watching for a while now, the BeagleBoard X15, and hopefully within the next couple of months, that's going to ship. That thing looks impressive. One of the interesting things about that to me is it's actually got dual gigabit Ethernet ports on it. So looking at it from the idea of a router or a network device, looks like it has all kinds of potential.
Cool. Yeah, we'll have to check that out. We haven't heard much of actually. I mean, I know they've been active, but the BeagleBoard or BeagleBoard Black was the last one that really came out in a big way. And then it's been a little bit quiet. We've heard a lot more from Raspberry Pi and Arduino folks, but it's good to hear that that's coming out. What about you, Guillermo? Any last thoughts on this topic before we wrap it up?
Well, I guess if people are actually really interested in getting into the open source hardware movement, if you will, I would probably say start out with the Beagle boards, maybe the Panda boards and all those variations. Basically, because you can actually get the specs for the Gerber files. You can get the BOM files list. Not that you'll actually start producing your own boards right now, but it does help a lot if you actually want to start modifying the board and you actually want to you want to gain the benefits of what open source hardware brings, if you will. Because if you're just doing something simple with it, you might not actually see that. But if you actually start modifying the board somehow, having all those files there will make a lot of difference. So I would probably say, just maybe start gearing towards the ones that do have more files published, if you will. And of course, I'll also look if you do spot a few Kickstarters out there that have published, like in this case, the Snickerdoodle, right? Have published the files and everything else. Give them a shot. Try and see what you can do. And obviously, if you're into this whole maker thing, try and modify it and try to do something cool with it. Something that is probably not expected. I guess that's it.
Yeah, cool. Nice last words of wisdom there. I really like that. Support open hardware, and by doing that, you're really supporting the rest of us as well. So we can have more of these options available in the marketplace. So great. Well, thanks guys for joining me. Since we don't have a guest again, usually we ask these last two questions: what's your favorite scripting language, and what's your favorite editor? In this case, because it's just us chickens here, I think I'll ask, what's your favorite? It doesn't have to be limited, severely to open hardware, right? So, but any of the platforms we talked about today, what's your favorite platform to use?
Well, for me, the Nucleo, I think I already mentioned. Oh, sorry, did I get that?
Sorry, that's my fault. I should have said, Guillermo,
Cool.
what's
Guillermo,
your
okay.
favorite platform? Right. Yeah.
Okay,
sorry.
I'll just finish then. Yeah, the Nucleo boards, the ST Nucleos, those are some of my favorite. And the alternative would be the Explain Mini boards, which are Arduino compatible. They even use the same ABR chip. This is one example here. And they also come with a programmer, everything in there, and they're super cheap too, maybe like $4 or $5. So if you want to get into ABR, that is a way you can do it. And if you want to use a big boy board, as I call them, and actually move into the Cortex line of chipsets, head for the ST ones, the Nucleos.
Yeah. Cool. Awesome. Jonathan, how about you?
At this point, I'm going to have to say the Raspberry Pi just because it's the one that's the most available and the easiest to work with so far. I had an interesting experience on vacation one time. I needed to do some hacking on some source code, and my wife had conveniently stolen my laptop that I was set up to work on. So I had a Raspberry Pi and one of their little 7-inch screens and then a wireless keyboard, and it propped the screen up on the keyboard and actually did my hacking on that, my programming on that. And surprisingly found it to be a decent experience. I was expecting it to be awful, and it wasn't. So the Raspberry Pi kind of won my respect when it saved me there.
Yeah, awesome. I think I would also have to say Raspberry Pi just because there's so much you can do with it. I love Arduino, and like I said, this little ESP8266 is can do a lot too, and I'm starting to like that a lot. But Raspberry Pi for me. And maybe it's because I know Linux already, and so it's easy for me to use that. But I really do like it. It's so versatile, and especially with this $5 Zero board out now, I've built that into a lot of projects. I've got a sprinkler, home sprinkler timer project I built all around the Zero. And in fact, that project I believe is going to be featured on the new screensavers at some point, so you may want to look out for that. Yeah, I think Raspberry Pi for me, for sure. I'm always afraid doing what you did, Jonathan. I'm always afraid taking it with me on trips and stuff, which I do, to work on it. And I'm always afraid they're going to stop me at the airport or something, and then I get it set up in the room, and it just looks like something, a bomb or something. And I'm always afraid someone's going to say something or get stopped or, heaven forbid, get strip searched going through the security line. Hasn't happened yet, so... I'll keep my fingers crossed on that one, but great. Well, hey, thanks a lot, guys, for joining today. I'm going to go ahead and switch gears here to things that are coming up next, and then I'm going to let you guys plug whatever you want. But upcoming on the show, the big one for next week, and I apologize for my dog. When the doorbell goes, he goes. Boy, that's loud. He'll stop here in a second. Okay. So coming up next on the show, big news. Next episode is episode 400. So this is 399. Next one is 400, and it's going to be great. So please join us next week. It's going to be really nice to get to that next level. I remember when we got to 100, and we were like, woohoo, 100. Now we're all the way up to 400. It's crazy. But next week for episode 400, we're going to be talking about Nextcloud, and this is something, Guillermo, that you pointed us to. So we're going to be talking about Nextcloud, and Frank, I'm not sure how to say his last name. Is it Karlichek?
That's close enough.
Okay. He's going to be joining us to talk about Nextcloud, which is kind of like a fork, if you will, of the OwnCloud project. And so we're going to talk about what Nextcloud is, how it's different than OwnCloud. I think it's going to be really interesting, so you really want to check that out. And then on August 30th, we're going to be talking about LucidWorks, which is intelligent enterprise search engine based on Apache Solr project and Apache Spark. So kind of like Google for the enterprise, but I think it also does some metadata searching, it digs into the documents and pulls some stuff out. So like if you're a research organization or something, sounds like it might be a really interesting project. And then on September 6th, we've got Midokura, which is enterprise virtual network management software built on the open source MitoNet project. So that's going to be interesting. And then September 13th, we have Project Atomic. I believe Josh Burkus is going to come talk to us about that, who I've met before. We've talked to him before. But this is basically, the way they describe it is you can use immutable infrastructure to deploy and scale your containerized applications on a next-generation container OS. So I think Project Atomic is both an OS and some other components that go with it. But it's basically built all around containers. And we talked about Docker and containers and Kubernetes and all those great things a lot recently. And so this is another one that fits in with that. So before we wrap up, anything you guys want to plug? Guillermo, let's start with you. Anything to plug this week?
Well, I guess you can just go find me on YouTube, since I do put out a few videos, modifying things and fixing my car, stuff like that. It's interesting. Just believe me there. You can look for my videos. Either search for Amaral and pick the one who is not a DJ. Okay. Although I've done DJ before, of course. Or just look for my name. There's my name right there. Just Google that and you'll find me.
Yeah. Lots of cool stuff going on your channel. I really like it. Jonathan, how about you? Anything to plug?
Sure. We've had something come up in the past couple of weeks. FWNOP GUI. It's the cross-platform desktop client for FWNOP. Just had a new release, doing some new things for the first time, supporting GPG on Windows and some things like that. Probably the most exciting thing, though, is that we've gotten accepted into Fedora. So starting hopefully in a week or two, and with Fedora 25, we're going to have FWNOP GUI in the main Fedora repos. Excited about that.
Awesome. We've got apparently people showing up at our door, so I apologize. You can follow me on Google+, Twitter, Facebook. I'm Aaron Newcomb, all one word, on all of those platforms. Just search for me. You can follow me on whatever your social media of choice is. Not really into Snapchat or Instagram, so sorry you can't really follow me there. But any of those three platforms, just give me a shout out and start a conversation with me anywhere there. As far as this show is concerned, you can follow us. We're at Floss Weekly on Twitter. We're plus Floss Weekly on Google+. And you can chat with us live. We're live. Excuse me. irc.twit.tv is the address where you can just jump in the chat. We always love to take questions from chat room. We had folks in the chat room guessing the boards that we were showing up, doing a great job, by the way. People were really getting the board. I was surprised how many people got the boards right. So we love to do stuff with the chat room and incorporate them as much as possible. And of course, you can watch any of the Twit TV shows live at live.twit.tv. That'll do it for this episode. And really thank everyone for joining. A little different this week, but I hope you enjoyed it. And we hope to see you next time right here on Floss Weekly.